Hello everyone. Today we will discuss the full wave rectifier. We have already studied about the half wave rectifier. So there were two disadvantages of half wave rectifier. One, it rectifies only the half cycle of the AC, input AC. Second thing, the output obtained is not constant. It has some ripple effect, or you can say it has some part of AC component. Though it is unidirectional, but it is not constant. So these were the two disadvantages. One disadvantage is converted into advantage by using full wave rectifier, where both the cycles are rectified. Both the half cycles of AC are rectified, right? So in full wave rectifier, both the half cycles of input AC are rectified, right? So what is full wave rectifier? It is the device which converts both the half cycles of AC into DC. So what is full wave rectifier? So it is a device, full wave rectifier is a device which converts both half cycles of AC into DC. So what is the principle? The principle is same as that of half wave rectifier. That a diode, PN junction diode, conducts in forward bias and does not conduct in reverse bias. Right? So what is the construction? The construction is that here we use two diodes. Right? Here two diodes are used. So how do we use the two diodes? The input is same as that of half wave rectifier. So input may we have a primary coil which is attached to the input AC, and this is a primary coil. Then we have here secondary coil. In the secondary, two diodes are attached like this, and these ends are joined together, and between the common end of the PN junctions, diodes of this is a common junction, the output is obtained between this common end and this center tap of the secondary coil. the output is obtained across this. This is called as center tap of the secondary. This diode is marked as diode 1. This is diode 2. Right? And this is the transformer. And this one is secondary coil, obviously. So what happens is, during the first half cycle, this AND, if I mark this as A AND, this is B AND, this is C AND, this is D AND, right? When in the positive half cycle, if suppose AND A is positive, this AND will be negative at that time. So obviously, if this AND is positive, since this coil is inductively coupled, mutually inductively coupled, so this AND will also behave as a positive polarity, and this AND will also have negative because this is inductively coupled to B. So you can say when AND A is in positive polarity, due to positive half cycle of AC, right? Then and C is also positive. What does that mean? Therefore, diode D1, this is positive, this is P of the diode. So you can say diode D1 is forward biased. Now at the same time, when this is in positive half, this will be having negative polarity. So you can say that diode D2 is reverse bias because this is negative and this is P of the diode. So you can say that diode D2 is reverse biased. Why is it reverse biased? We can mention here and B and D are negative. Therefore, diode D2 is reverse biased. Here D1 conducts and D2 does not conduct. Right? And in the next half cycle, what happens? In next half cycle, I am just symbolically drawing here. In next half cycle, this end is negative, so this end is negative, this is positive and this is positive. So we can say A, B, C and D. This is diode D1 and this is D2. So in this half cycle, what happens is, and A is negative, therefore and C is negative, therefore D1 is reverse biased, therefore does not conduct, right? And here this and B is positive, therefore and D is positive, therefore D2 is forward biased, therefore D2 conducts. So this is the construction and this is the working. We can draw this waveform, input and output waveform for the full wave rectifier. So this is, here I will draw input waveform for D1, input waveform for D2, and this is output voltage across load resistance, right? And this input waveform for D1 voltage, right? So we know that the input waveform is alternating current. So you can say that for D1, if D1 is having positive polarity, D2 will have negative polarity. So in output waveform, this D1 will conduct as it is forward biased. This is D1 waveform, this is D2 waveform. Now for the next half cycle, D1 becomes negative, so D2 becomes positive, right? So D2 conducts because D2 is forward biased. So this is D2 is positive here, here D1 is negative. Similarly, when it again is in the positive polarity, this is D1, this is D2, and at this time D1 conducts. So what is the advantage over here? The advantage is that it conducts this, it rectifies both the half cycles of AC. So this is the advantage of full wave rectifier. It rectifies both the half cycles, or you can say complete cycle of AC. And what is the disadvantage? The major disadvantage is that though this current is unidirectional, but it is increasing and decreasing in value. That means it is pulsating or it is having a ripple effect. So we can simply write that it gives unidirectional output, but it is varying. Varying means therefore it is pulsating or having AC ripples. Why we are calling it AC ripples? Because the value is increasing and decreasing, increasing then decreasing and then increasing and then decreasing. That means it is having AC ripples. Okay, so this is corrected, this advantage is removed by using filter circuits. Therefore filter circuits are used to its output to remove this AC ripples, right? And important thing, one more important thing is, what is the frequency of a full wave rectifier? This is twice of the AC input, because in every complete cycle it gives output 2 times, right? So you can say it is 2 times the frequency of input AC. So let's take an example. For example, if AC input frequency is 50 Hertz, then for half wave rectifier is same as the AC input, but for full wave rectifier is equal to 2 times of 50, that is 100 Hertz. So this was all about the full wave rectifier. Hope you understood the topic. That's all for now. Have a nice day.